Hi everyone, I'm Zhaowen Guo from Better Government Lab, Georgetown University, and excited to kick off lightning talks and share with you open source tool our lab has been developing for SNAP payment error reduction. SNAP is large and consequential. In 2024, it serves 41.7 million people each month, about 1 in 8 Americans, but accuracy is under strain. The national payment error rate was nearly 11%. And now, under H.R. 1, beginning in 2028, states with a payment error at 6% or above will be required to submit corrective action plans and also undertake parts of the benefit costs. As of now, 44 states are already at or above the threshold, meaning real fiscal exposure, unless accuracy improves. This motivates us to develop open share tools that help states turn quality control microdata into objective evidence and reproducible guardrails, so states can learn from their past errors and drive down SNAP payment errors faster. The first tool we built is called SNAP QC Error Viewer, which allows us to see errors faster. It turns SNAP quality control microdata, which is a federal state reviews of sample SNAP cases every year, turning these dense records into a shared interactive dashboard. We built this dashboard with input from QC auditors and policy experts to harmonize definitions and measures across years. It's built for state QC leads, policy analysts, and civic tech partners to identify which area to focus on, as well as to prepare briefings. And with this tool at a glance, you can filter by state and year, and you can toggle between how often an error occurs and dollar amounts it drives. So it allows you to quickly surface clusters, dollar drivers, affected groups, and responsibility patterns. As of now, this app supports 4 different types of views. First, error pathways on the top left. It creates Sankey diagrams that based on natural QC investigation, starting from what went wrong to how it happened and why. So you can trace errors end to end and see whether this error is attributable to agency, client, or technical issues. And then error demographics. By creating bar charts, you can visualize whether a particular social or demographic group is disproportionately affected by a given error. And it also supports side-by-side state comparisons. And then error severity. It allows for ranking error category based on dollar impact or frequency of occurrence, so you can target specific fixes with the biggest payoff. And lastly, pivot table tabular. It allows you to generate customizable tabular summary that you can slice, export, or drop straight into the corrective action memo. And based on these errors, we also constructed SNAP QA benchmark dataset that allows for evaluating and comparing whether AI models can effectively handle error scenarios that actually happen within SNAP. So here's how we put together this benchmark dataset. We began with extracting error components from QC data, and then we have one QC auditor write seed questions. Based on those seed questions, we asked GPT-4o Mini to generate batches of base questions. And then we have 2 QC auditors independently review and revise those base questions, specifically tightening wording, assigning difficulty level, and also identifying, ensuring there is one single correct answer to those multiple choice questions, and flagging whether the correct answer will depend on client attributes or state policy specifically. As a result, we have this QA benchmark with roughly 800 questions aligned to real SNAP quality control errors. And now this dataset is hosted on Hugging Face. Our benchmark dataset is grounded in real impact by focusing on QC pathways targeting high dollar, high frequency mistakes. And the question setup is also closely aligned to benefit navigators' decision-making process, so it's very realistic and decision-focused. And this dataset also allows for detecting model bias by including questions where the correct answer are sensitive to client or state attributes, so that we can detect one-size-fits-all model failure points. This dataset is also policy and procurement friendly. With this shared transparent benchmark dataset, states and vendors are able to compare models fairly. And on the right, you can see one sample item from this benchmark dataset focusing on the error category income calculation. So the question here describes the client scenario with a list of client attributes. The correct answer here is option D. But if we toggle employment status from seasonal worker to steady employment, the correct answer will switch to option B. By including questions like this, we are able to detect whether model responses are reflective of those attribute changes. And currently, our research team has been working on expanding this QC error viewer with more years of coverage and more useful variables, augmenting this benchmark dataset with including reasoning quality checks beyond factual accuracy. We've also set a policy evaluation pipeline to identify which policy levers are more effective at reducing SNAP payment errors. And you are welcome to explore these tools and datasets further by scanning these QR codes. And if you have any questions or feedback or would like to partner on data and evaluation, we'd love to hear from you. Thank you.